All right. Welcome, everybody. Today we're going to be talking about securely deploying infrastructure as code. My name is Chris Ayers. I'm a senior customer engineer at Microsoft. I'm actually part of the Azure engineering teams. I'm on a team called the Fast Track for Azure. One of the things we do is we help customers deploy their solutions to Azure. We help them do it more securely, more quickly, kind of accelerate their adoption of Azure. And that's one of the things I do. And I'm actually one of the category leads for DevOps on Fast Track. So I talk with service leads from across Microsoft, leveraging different technologies through DevOps practices. You can find me on Twitter, Mastodon, LinkedIn, and there's some blog posts about this topic on my blog, and all of this code and all of my samples will be out on my GitHub. So I want to start with what is infrastructure as code, just at a kind of a high level, what we're talking about, security tooling, some of the choices out there and why we might want to use them, how we can deal with rules and customizations, some of the workflows we can leverage for leveraging security in Terraform. And then we're going to look at a bunch of the integration points, like pre-commit hooks. If you guys aren't aware of those, they're awesome. Some of the extensions for VS Code and how we can integrate them into our pipeline through actions. So, infrastructure as code. I think a lot of us might be familiar with it, but this is a way that we can manage and provision our infrastructure. We have it checked in, we can use config files, we can do pull requests, we can review it, and because we can do infrastructure allocation through code, we can also analyze it and use security tooling to try to look for some of our biggest problems, like misconfiguration. A lot of the tools I'm going to be covering today are SAST tools. So they're static analysis tools. These are going to be analyzing your HCL files, the HashiCorp language Terraform files. And that's how they operate. So it can look for properties that should be set that aren't set, or maybe properties that have been set incorrectly. And I don't think I'm really speaking new information to anybody here, but why would we want to use security tooling on our infrastructure as code? I know that we want to do it when we're monitoring, we want to run it on our software that we're building, but the infrastructure we build is as fragile sometimes as the software we build. We need to catch these issues early, and in a lot of cases, in a lot of industries, we have to do compliance. We have to make sure things meet all the regulatory needs that we have. This will let us improve that security over time and save a lot of not only bad press, but issues to our organizations. As far as compliance goes, there's been a lot of breaches due to misconfiguration. There's multiple reports out there of storage accounts being left publicly accessible, databases that have public IPs associated with them, rules that aren't being set in firewalls, identities that have full access to things. And a lot of times you can look right over them and not even notice the misconfiguration. So this is where the tooling and the rules can come into play and help us identify these very quickly. The OWASP Top 10, that's been talked about a lot. So we've seen from 2017 to 2021, security misconfiguration is number 5 on that list. We're misconfiguring our stuff. Kubernetes, number 1 is like insecure workload configurations. So configurations are things that are so easy to mess up. If we go out here to this, like 20% incident rate. It's moved up. I saw a number of reports that like 99% of businesses are going to face some sort of security issue, and most of them were like users' fault through misconfiguration, through inappropriate, not scanned properly. 60% of businesses that have breaches, most of them are going to be coming from some misconfiguration as well as through hacking attempts because of that. So it's definitely something that we need to be aware of and keep in mind. So we can't just wait till it's running out there in production. We can't. I've worked at organizations where, we've built the app, we've got it ready, and then right before we go to production, hey, let's do our security audit. Let's do our security review. Those days are long gone. We can't operate like that. Even going through a pull request, sometimes when you get to that pull request point, it's too late. You've already started committing to an architecture, and you need to start catching those things earlier than a pull request. So I'm going to show some tooling that helps from the developer standpoint. Now, all of these things are specific to Terraform, but they do more than just Terraform. Many of these tools will also look at Docker files. They'll look at Kubernetes configuration files or Helm charts. They'll look at pipelines. So you can leverage these as part of your bigger ecosystem of tooling, but these are really great for looking at Terraform in its own way. A lot of them will start with just the HCL file. So Terraform files are all written in HashiCorp language. It's a domain-specific language designed for infrastructure as code. This can look at the raw files of the Terraform modules and can find those misconfigurations. But a lot of the tooling can also look at your Terraform plan. Terraform plan happens after it takes all of your variables and your inputs and figures out what it wants to actually build, like with real names and security. So you can analyze things from both your raw files as well as your interpolated strings and resources so that you can look at the actual plan to do the analysis. So we can leverage both of these to kind of give us a better picture into what's going to be happening. I've looked at 3. I've already talked with some people. There are more, and they all have varying degrees of support. The 3 I'm talking about today are tfsec, terrascan, and checkov. Now, all of these you can integrate with your CI/CD, multiple rules for each service. You can write your own custom rules. Some of them use Rego, like right out of OPA. So we can use Rego to write some rules for some of these. You can whitelist things. You can also ignore things. So there are capabilities to set like an expiration time. Like I want to ignore this rule for a week. You can do that. You can have your own custom ruling. Now, tfsec, that one is supported by Aqua Security. You might know them from some of the stuff they do with Trivi. Terrascan is, I think, through Bridge Crew. And checkov, brain's skipping me, but I think that might just be my checkov. But all of these are out on GitHub. All these have, you can go in and look at the rules that they've written and developed. I'm going to show some examples of how to ignore rules, how to override rules. And when I say override, that might mean there's a vulnerability that it says is low. And in your organization, in your industry, that might be something that's required. So you might make it a high or a critical so that it is acted upon, breaks things. And then you can add your own additional custom rules. And there are some of those out there on GitHub that you can find and consume and share with others. So starting with tfsec, like I said, it's a stack analysis tool. It does support kind of like OPA Rego style policies. They provide a VS Code extension, which I'm going to show you so that you can integrate it into your editor as you're writing infrastructure as code. It also supports like pre-commit hooks, so we can actually stop insecure Terraform from even being checked in. It also integrates with GitHub Actions, and then we can use the PR commenter to add any passing or failing test information onto the PR so you can see it right during the PR discussion. You can see here some of the failing results of the tfsec scan. We're also going to talk about terrascan. This one, like I said, is one of those tools that supports multiple clouds. So pure Terraform, but it also supports like AzureRM templates. It supports GCP and AWS. A lot of Kubernetes support, Docker file support, and it will actually check your GitHub workflows. Like if you maybe have too much permission on your workflows, it'll be like, somebody malicious might be able to modify your code. You might not want that. this also supports Rego policies. So you can see some of the skipped validations, some of the summaries. Occasionally, some of these tools can also offer fixes as well as links to documentation on how to resolve the failed policies. And finally, checkov. Okay, checkov was bridge queue. Okay. Tenable is terrascan. My mistake. Sorry about that. This is Python based, so this is not Go or Rego inspired like some of the others. This is more Python based, but it does support multiple languages and Kubernetes and Docker scanning. So like I said, you can layer multiple of these tools together. There's another tool that I just wanted to throw in here because I thought it was interesting for those that are very developer focused. You can do BDD, like compliance testing with this project, which is really interesting because you can write like cucumber, like gherkin type syntax, and that can actually generate the appropriate tests for you, for your infrastructure. So I came across this, I thought it was really cool, and I wanted to share it. I just like sharing interesting things. So I'm a big fan of kind of layering these. Each of these kind of looks at a different aspect. Their rules are not 100% Venn diagram like one circle. Each tool has some policies and rules that cover some and ignore others. And by leveraging multiple of these tools, you can kind of get better coverage. Now, you can also face the small problem of maybe a little bit too much noise to the real signal. That's where looking at how to ignore or whitelist certain rules can be very important. So let's look at the workflow, and then we're going to get into a lot of demos. So are you guys familiar with pre-commit hooks? I'm sure some of you are, but everybody a big fan of them? Like, yeah, I love pre-commit hooks. I think they're really interesting. There's a pre-commit framework, and I'm going to show you that. And then we're going to dive into the extensions for some of the available tooling and the CI/CD integrations. So pre-commit hooks. So when you're dealing with Git, there's a couple of things happen. A lot of times when we're talking about CI/CD pipelines and we're talking about running things for validation in our pipelines, it's already been committed and it's already been pushed to the cloud. So if you've checked in a secret, if you've checked in the wrong stuff and maybe like started to build it, it's already committed, it's already in the history, and it's already up there. So the way we stop that is during the commit process, when you start a commit, there's a pre-commit hook so that you can run tests before it actually gets written to the disk and actually gets saved or even gets committed. You make the committed object, you get your message, and then you save it to the file system. There's another hook that is for when you're pushing stuff to your origin, the pre-receive hook and the post-receive hook. So like GitHub secret scanning, that kind of happens on the pre-receive hook. So maybe you've committed it locally, but they won't let you push it to the cloud. And the pre-commit framework is something that is phenomenal. So this is the pre-commit framework. When you add it, it's Python-based, and it runs off of a YAML file. So like, this is our YAML file for pre-commit. And it will pull from different repositories options like executables or scripts that you might want to run every time you try to check in a file. So for this example, every time I try to check something in, it'll make sure it's valid YAML, that there's no end of file new lines, there's no ending white space. You can do different scripts automatically, and tfsec, terrascan, and checkov all have through their own support or third-party pre-commit hooks to run those tools. The other amazing thing about the pre-commit framework is it will let you download the required executables or like download the dependencies before it needs to run them. So it's really nice. So let us come over here to VS Code, and let me switch to a pre-commit. Slash that. All right. So I've added a pre-commit hook here. So I've got some of the normal, like white space, YAML. I've got one from Bridge Crew for checkov. And then from Gruntwork, I've got tflint and Terraform format and validate. So every time I try to commit something, it can run a format, it can run a validate, I can run checkov. And one way you can do this is you can run pre-commit, run on like all your files. And that happened really fast. But you can see, oh, it found a trailing white space, some files were modified. It noticed there was an end of file thing, and if I check over here, some of these files were all changed. If I try, I'm manually running it right here. So that's just me manually running it. Let's say I want to bring in some files from a demo, and I want to try to commit those. So I want to commit these couple of files. So it's taking a little bit because it's getting, it's running the checkoff, which the first time you run it on a branch, it might take it a sec to pull down some of the policies. But what I'm expecting to see is this commit to fail, to not let me check in this Terraform that I brought in. Now I can manually run it by hand, but I'm kind of wait for the commit to go through. Let me see if I can bring up my console, get the output. All right, I'll just run it by hand. Yeah, so it's like I said, it's the checkoff that's taking it a sec. Once you've run it once or twice, yeah, so it's not even going to let me check it in, but it's already run a bunch of, yep, there it is, show command output. So this was the output of the check-in, and it's passed, you can see it's running various checks. And we'll dive into what those checks are, but I have a storage account. Ensure that they use replication. Ensure they have strong naming accounts. Ensure I have trusted services or only HTTPS. So right now I've got this storage account exposed to HTTP. I mean, let me go take a look at this terrible insecure thing, see what we're talking about. It really is one of the samples right out of the documentation. Like, this is right out of the Terraform docs. So if I went out to, I know it's shocking, right? So if I go out to the Terraform docs, this is what we've got. We've got standard, GRS, and a tag. That's all we've got there. But if we look at the output of checkov, for instance, and we dive into what this is saying, ensure critical or replicated with maybe a customer managed keys. There was the one I was looking for. There was the HTTPS one. Yeah, it's found stuff in a number of these samples. App services, looking at error messages. Like, that's not important, right? Disable HTTP. Yeah, who cares? Those aren't very important. So how do we control these a little bit and learn more about them? Well, one, there's a guide here. There's documentation. And this is pretty much the same on any of the services that we have. So if we go out here to like the Bridge Crew docs for checkov, they've documented each and every one of their checks. Now this applies to AWS. You can see there's a bunch of AWS policies, there's Kubernetes policies. Here is our Azure policies. And they have an index of all of the various, let's look at the general ones. Do we want to make sure that we have alerts set or threat detection? So just out of the box, we can leverage some of these to improve the security of our individual applications. Now we can learn from these and go, oh, this is way too much noise, for some, We want to make sure TLS is set. Well, looking at this, it's telling us how to fix it in the CLI. It's also saying, hey, in Terraform, we really should add min TLS version 1.2. If I'm looking at my code here, let me close my terminal. Because I've added the extensions, and I'm going to dive into them in a sec, I'm also seeing the alerts right in my interface in VS Code. And I can get the links to these specific things. So if I add my min TLS version, that should get rid of one of them. Now, you don't have to have the pre-commit hooks. Like it can slow you down every time you commit, but it's also a good thing. It's a reality check that you need. And looking at these, we can, going back to the documentation here, it's very easy to whitelist, tweak them in some way. They have for some additional dashboarding and tooling for their stuff, but most every time you want to ignore or whitelist or enforce a rule, it's usually some sort of comment right in your Terraform, and it's documented right there. Like checkov, ignore, and you put the specific rule. A lot of times they have an option to let you have a time period with an expiration, so it's good for 24 hours, it's good for 48 hours. There's also configuration files. Like we can, on some of these, we can specify overrides. So tfsec, for instance, the HTTPS is a low warning for tfsec. I might want to make it a critical warning. So this stuff is very easy to tweak and customize. Let me go back to the slides. So that's how we can do the pre-commit hook. And like I said, let me just finish that thought. So tfsec, for instance, you'll find that out at tfsec.dev. They have a lot of documentation there. They have the guides that you can easily add it. They have installations for installing it through Go, installing it locally on the machine, and then out in their code repo. This is where they have their pre-commit hook tfsec right here. So they have, I want to use Golang, I want to run tfsec, I want to scan for Docker. That one has one. You already saw the checkov one, and then terrascan you can install through the pre-commit hook. So IDE-wise, terrascan doesn't really have a plugin, but checkov and tfsec do. So this is a Visual Studio Code plugin where it actually adds into the editor over here on the side tfsec, and you can hit this to download the latest version of tfsec if you don't already have it, and then you can run tfsec against your current environment. And it'll give you the output, you'll see all the rules that it's run, scan all the files, and then it will update the findings explorer over here on the side. So I can look at, oh, I have a key vault issue in this demo. I can see down here the specific ID. So if I need to whitelist or ignore this rule, I can take this specific ID of the rule. Impact, so it'll try to explain why the rule is triggering, and why it's important, and why you need to resolve it, and the specific file that was affected. And Aqua's usually really good about stuff, so they have links right to the specific write-up on that rule. So, and with a lot of stuff, it's just a little bit of Terraform that is the difference between something that's secure and something that is wide open. And it's so easy to miss. Like, I know there were some previous talks about code reviews and PRs. We were joking, if it's a 500-line PR, hey, it looks good. If it's a one-file PR, you missed a semicolon, spacing, like indentation, like this stuff slips through so easily. So the tooling can help you do that. So that's the tfsec extension. The checkov extension is a little different. It doesn't actually add on the left-hand side of your bar. You got to kind of bring up the command palette, and it provides a couple of things. You can install or update checkov. They have specific settings you can get into, and you can see down at the bottom of my screen the version of checkov I'm running, which is 2.2. So I can run a checkov scan, and it adds its output to the problems. So it's showing me for every single file the security issues that checkov has found with links to the specific checkov rules. So both of these are phenomenal for improving infrastructure and development awareness during that inner loop. All right, well, let's say, people aren't using pre-commit hooks. Let's say they didn't install these extensions. How do we integrate these with a pipeline? How do we kind of get this stuff running in our PRs? Well, for that, one other small thing. If you are using dev containers, like if you're using containers to develop your stuff locally, like you want to have Python installed in your Docker container, there are features available to add to your dev container so that even if you don't have tfsec and terrascan and checkov installed locally, you can add in your Docker file features for tfsec and terrascan. And so in my repo that I'm using for all the samples and all the demos, I'm using a dev container, and I've added like all the tools I want to have available when I'm playing around. So I've got AZTerrify, I've got tfsec, I've got Trivy, I've got checkov and terrascan all added, and I'm doing the terrible thing of using a jammy base image because I'm playing around locally. It's not like I'm running it in production or on Kubernetes, but I don't have to worry about collisions with my local OS or WSL and my Windows command line and whatever. Like, I know if I fire this up, I have all the tools I need. All right. And I think I just closed my browser window. Yep, there we go. All right, so pipeline integrations. So there are, most of these are official actions. Some of them have some limitations, and I want to talk about those, and I've added some additional ones. So tfsec actually provides two extensions. One is the tfsec action right there, where you can just pretty much, you clone your repo and you run tfsec, and it'll run it against its predefined tools. And if it fails, like you don't have a lot of official options, but you can do all the command line stuff with additional arcs. So like you can have it soft fail, so it just adds to the PR. You can, what I've had to do is I changed the format to JUnit. I actually changed the format to JUnit for all of the tools so that I can use a test results uploader to have them comment on the PR, so it shows up really easy and clear. I wasn't seeing the results in the PR without that. But yeah, it's pretty much just add that JSON file, and I'm going to dive through mine. And then, like, this was not working. So there's multiple issues. There's a lot of open issues out on this one. This is supposed to take the output of tfsec and add it to your PR. It wasn't working for me. And like I said, there's a number of open issues where other people are having that problem. Terrascan and checkov are very similar as far as you can just run it on your job, check out the code, run terrascan. The problem with this one is I couldn't control the output very easily. Like I was having issues trying to get it to add to the PR. Like it wasn't outputting the file right, but it still is working. And then checkov, you got a ton of options. If you have GitHub Advanced Security and you have CodeQL, you can output via Serif, and you can add that into your CodeQL and security tab. So let's take a look at that. So all this is out here on my Secure Terraform for Azure tab, and I've got all of these workflows in here. So I've tweaked them a little bit. So starting with tfsec, I have it running on every pull request and when it gets merged into main. So that's how I've got it running. Checkov was complaining I was giving it too many permissions. So I did limit my permissions of my workflows. So it helped me while I was writing this. But you can see I'm outputting in JUnit format with all of my results, and then I'm using this publish unit test result action to upload that into my PR. And what that looks like on a PR, let me go get one of my closed ones. I've got it commenting right in my PR, all of the results of my tests, and I can actually see how it's changed over time. You know, it's showing me what I tweaked, but yeah.
Does this also need GitHub Advanced Security, or is this?
Nope, none of this needs GitHub Advanced Security. This is all base GitHub. These are just normal public, private repos. Yeah, so I've got all those checks running on that, and you can see the results of the checks under the checks API here. You can dive into like tfsec. If we come down into this, like it does output the what it's trying to do, and you can get the specific version it was running and all of those outputs. And then checkov will also output all of that. The one that I said was a problem is terrascan. Every time I was trying to get terrascan to output effectively, it would not add to the PR. I couldn't, I'm going to submit a PR to the terrascan action because it doesn't expose the output options that are available on command line. So it spits it out here and isn't, yeah, see it's spitting out here. And it's not letting me add it to the PR. But I'm getting the same information. It's just, it's not failing when it should be failing. When that's a failure specifically because it should be alerting. I don't have a resource lock on my resource group that I was leveraging. But yeah, it'll do Serif. I'm not using Serif. Now, all of these, the way, and I don't know how familiar everyone is with GitHub Actions. The way GitHub Actions work, if you have a YAML file in the GitHub workflow folder, it's a valid workflow. It'll run these on any event that happens. So if the event is on push, it'll run this. If the event is on push or on pull request, it'll run these every time. You just create the file, it'll run them. So when I try to run this stuff, it'll run all 4 pipelines at the same time. It'll run all of them. So I can have all of them as an indicator of whether I want to continue with the PR or stop the PR, ask questions about it. And so let's try to merge this one in. I think I accidentally went forward one. So let's create a pull request. So I want to bring in all of that stuff that I've got, and we've already got some checks kicking off. So I had said terrascan and checkov and tfsec. So these are starting to run. Yep, and checkoff failed. Let's see why. Oh, it's looks like a pathing issue, or yeah, I limited the checks. This was an older workflow file, so I had limited my permissions a little bit too much, but we should start seeing some of the errors in the actual tfsec logs. Yep. Yeah, it had some failures there. So, yep, there's their comment, and we had some failures. So I can go into the check, and I can see the specific outputs of that. I don't have a network ACL, and my app service doesn't have the right authentication enabled. So now we can start getting some information about our specific infrastructure every time someone tries to submit a PR. These are all using open source tools, using just regular GitHub Actions. Now, any questions on this stuff so far? Yeah.
So if I'm not on GitHub Actions,
You,
on GitHub.
if you're on Azure DevOps, you can install and run these tools yourself, and you could still, just like I was, you can generate, you know, I want -F for JUnit, I want to output in Excel, and you could do like a JUnit upload. There's ways to install all of these tools. So a lot of times there's ways to run them as Docker commands. So if you want to run them as a Docker command from inside your pipeline. This specific example is using GitHub, but because they're open source tools written in Go or Python, you can pretty much run them wherever you want. You can invoke them on your code base. So like I said, I have this running locally. So if I do checkov my SD, it's going to run checkoff against my current stuff. So if you can run that in your pipeline, you're good. You know, if I want to do tfsec, I can run it locally, and I can get information about my stuff, and same with terrascan. So this is just, I've automated it and put it together with Actions, but you can do this with other CI/CD platforms. They do have how to install it on a Mac and on Windows for pretty much each and every tool. Does that answer your question? Yeah.
If you're not using Terraform, I'm using Ruby. Do you know if checkov has support for Ruby?
I would have to check. Yeah, I would check on each specific tool, but from what I've seen, they support native AWS CloudFormation. They support GCP, whatever their thing is, and then AzureRM templates and bicep. So your mileage may vary if you go outside of those. So, any other questions? Okay. So the next kind of thing I think that is important when we're talking about infrastructure as code is our backends. So I know that when we're writing at Terraform locally, a lot of times we don't think about it, but you know that local state file, it has all of your secrets. It has access keys, certificates. Like if you have access to your TF state file, it has everything. So a lot of times the recommendation is to host it in a cloud provider or use something like Terraform Enterprise Workspaces. Now, in my examples, I'm going to be using AzureRM as the backend, and you can see down here, and let me just zoom this in a little bit. There are a number of available backends: Azure, Console, Kubernetes, S3 buckets. One thing that I've been doing, and let me switch back to my main code base. And I will show you. There are a lot of things that you can override from your Terraform. So there's a number of different patterns for doing multiple environments in Terraform. You can have, you know, one big folder with multiple TFRs. You can have different folders for each environment. You can use a common module directory with, you know, a folder for each environment. In this particular case, you know, I'm just doing some basic Terraform. I'm not doing a lot. But notice I'm using AzureRM for my backend, and I have no configuration checked in. Like, there's nothing that shows where it's going. I'm going to overwrite it all in the pipeline, and I'm going to define where that state file gets stored. If you're using workspaces, I think it uses one common state store for all of your workspaces, so you could have non-prod and prod state mixed together if you're not careful. The other thing to be aware of is if you go out with the samples, so if you start with like that wonderful sample we did on like a storage account, or you just come up here to the AzureRM provider. This says, hey, I want to, 3.0. Like out of the box, you might just go, okay, yeah, that looks reasonable. Yeah, let's do that. Let's just do 3.0. The problem is when you start using the backend provider, I want to not use passwords. I don't want to store a service principal. I kind of want to use OpenID Connect. Google or GitHub has this awesome OpenID Connect relationship with Azure, and I want to use OpenID Connect from GitHub to Azure, and I want to do it with my backend for Terraform. So I don't want to have a password. I don't want to store a service principal. I don't want to store secrets. I really just, what you need is usually a client ID, a tenant ID, and a subscription ID. Those three things. Well, the thing that you might not catch that will annoy you no end if you haven't caught it before is OpenID Connect is only available at 3.7 and above. So if you're using 3.0, like you'll have it configured, you'll try to make it work, and it'll just blow up in your face every time, and you'll pound your head against a wall for a while. Like you need at least a certain version of the AzureRM provider to support OpenID Connect from GitHub to Azure. So that one, twice now, I've forgotten that, and it has bit me in the butt. So I'm talking about OpenID Connect from GitHub. What does that look like? And like I said, there's other backend providers. There's even on learn.microsoft.com, Terraform on Azure documentation and how to store your state file in a storage account. So it's well documented how to do it. And we're going to override it all. But OpenID Connect. So GitHub has implemented OpenID Connect for pretty much all of its auth to the major clouds. They really want you to leverage this, and so they have this trust between GitHub, Azure, AWS, GCP, HashiCorp Vault, and essentially, because these two organizations trust each other, when your action in GitHub runs, it'll provide a claim to the cloud, say, hey, I am so-and-so, and you can identify me via, I'm coming from this org, I'm coming from this repository, I'm on this branch, I'm in this environment, so you can be very explicit, like what piece of code is running and asking for permission, or asking to identify itself to Azure or to Google or to whatever. And it used to be that you would have to go out to the portal and manually kind of do this in Azure AD. You would have to create a service principal, create an app registration, and then add what they call a federated credential. Let me go down here. So I would create a registration, and then if you look here, these are my federated credentials. And the subject identifier, so from my repo, like my org, my repo, it's a pull request. My org, environment, prod. My org, and you can have multiple, identifiers. It's an or, not an and. And this is a limited example, so I have both dev and prod listed here. But you would probably have a separate identity for non-prod and a different identity for prod. And then now that I've identified from GitHub to Azure, I want to deploy, I would assign the relevant permissions to that identity. Now, it's all documented on the GitHub site for all the different clouds. So if you use them, they provide you information on how to do it. You need to have like permissions for your token in the workflow, and then they log in this way. And the reason I bring up OpenID Connect as a very part of securely deploying is, for years, the way Azure login was recommended to work, and you can still kind of see it here, you know, they said they have two different ways: service principal with secrets or OIDC. And they recommend OIDC. The old way, and this is the way it's always been done, AZAD-SP create. Like, who's done that one? Yep. And then you just take this big block, you know, ignore the secret. Who cares? Just you take that, you paste it somewhere. You know, you probably keep it around, whatever. You don't have to do that anymore. In fact, one of the things I want to provide as an example in my repo, if I can find my tab again, is I wrote with some coworkers, we've got a script. So I actually have a little bash script that will pull your org name out of your current Git repo. It'll pull your repo name out of your current Git repo based on your remote URL. It'll do an app registration in Azure. It'll then pull the object ID and app registration and create the federated credential for you in Azure based on, what do you want? You want a pull request? Do you want an environment? Do you want your main branch only? Only your main branch with your prod environment can authenticate to Azure? We can do that. And then it links it all together, extracts out the 3 pieces it needs, and sets them in your GitHub secrets. So using the GitHub CLI, you can create GitHub secrets from your command line for your repo. So you can just take this script, drop it in your repo, run it, and if you've authenticated to Azure and you've authenticated the GitHub CLI, it will wire up OIDC for you, which is fun, because otherwise it's annoying. That's fun. And then once we've done that, instead of passing this thing with creds and some secrets, you can pass the 3 elements that you need. So I've done that, and let's take a look at some examples. So I wanted to have a backend store my Terraform state in Azure, and I wanted to do it securely. So in my workflow here, what I've got is, for dev, I actually have two jobs. One is, and your mileage may vary on this, I'm doing this because I delete all of my demos in between talks, so I need to recreate things every time. I'm pulling out the couple of things I want, but then I'm setting some other variables. Notice I'm setting an environment variable based on a storage account name, a container name, and a resource group name. And the reason I'm doing that is I'm creating the resource group from scratch, I'm creating the storage account from scratch, and I'm creating a storage container, like TF state. Like if I've completely deleted my Terraform state, this will recreate it every time, the storage account, Terraform state, and all that. So it creates it. How do I wire that into Terraform? If you remember, my Terraform config is empty. So how do I tell it, I want to use OIDC Connect, and I want to use Azure Storage to store my state? Well, notice so if you do an AZ login before you do a Terraform init, it'll complain. It'll say, you need to log in as a human. Don't do that. So that's why it's a separate job. I just check out my code, set up Terraform, and I don't log into Azure. I'm just passing these couple of values here. And I got those values, shockingly, from the docs. The docs are where everything is. So AzureRM backend, and it's something you really need to pay attention to as you look at different clouds. So if we look at different clouds and we come down all the way to the bottom, configuration variables. Now notice there's required ones, but then notice this. They sometimes said, instead of just a command line option, you can give it an environment variable. So for some things, you can specify an environment variable, but I can't for the resource group. It won't let me pass that in as environment variable. But it will let me pass in the subscription ID and the tenant ID. So I have to do a combination of, I'm going to use OIDC, I'm going to use these things, and then I'm going to override my backend provider. And so that's what I've had to do here, where these are going to be picked up automatically by Terraform init because I use the right environment variable that it responds to. It doesn't respond to these, though. These were not environment variables I could pass to it. So I have to pass, whoops, sorry about that. I have to pass dash backend config, the name of the variable it wants, and then I can use GitHub to do the interpolation to reference the environment variable. So you have to kind of use a combination of the two to get it to dynamically override the backend with OIDC. And I just got it doing a plan, and this is after the merge. So the PR's already run, terrascan's already run, tfsec and checkov have already run, and then when I approve it, this will then deploy it out. And I can do a completely different, notice this is exactly the same as prod. The only difference is I'm using secrets from a different environment. So in GitHub, you can have environments. Each environment can have secrets. You can name them the same thing, so you just say uses environment and all your stuff works the same, and then you can have approvals. So if I go look at my my action run, you'll see, hey, when Terraform ran, first thing it does is I've got 4 states down there at the bottom. It does my dev state, creates the relevant resources, you know, and then initializes Terraform with the right values, and you can see it stars them so it doesn't output them on the screen. GitHub's usually really good about knowing that you had a secret that has some value and it's not going to print it out. If you do a lot of manipulation, though, you can shoot yourself in the foot. So any questions on the OIDC and backend override? Like if you're used to checking in your full backend config, like the name of a state file and the name of a storage account, and then, you can also not check one in at all. And then if you want to play around locally, you can add something like an override TF, so that instead of trying to do a remote Azure, this will locally let me play locally, and I can deploy it somewhere else, and it'll just keep my state locally while I'm playing. And then when I check it in, it'll go back to using Azure for everything. Questions? Yes?
When using AzureRM,
Yeah.
sometimes you might have a perfect defined Terraform configuration, and then if you change property, it might recreate a resource.
So the question was, sometimes you have a great Terraform file, you make one small change, it starts deleting things and rebuilding them. So that is an inherent problem of every provider. It usually varies by resource. So some resources, like in Azure, there are some specific resources where you can't change them. And so if you have it and you make a change, the only way to fix it is to delete it and recreate it. Just like with ARM or Bicep, sometimes if you create a resource with like an empty array of subnets, and then later on you do a child resource that's a subnet and you link it to it, every time you deploy that, it'll delete the subnets and then recreate them because the parent was empty. And so every time it's like, well, nope, there aren't any. Oh, wait, oh, you wanted me to add one. I think that varies. AWS and GCP do the same thing, depending upon the resource. That's why you can do a plan and you can have it pause and have someone like review the plan. Like you could do a Terraform plan and have it output out as like a PR comment, or even just as an output from a step in GitHub, so that you could then review it and do the approval. Like I can do approvals in GitHub, like it'll pause and say, hey, there's a deployment to prod waiting on your approval. Do you want that? Yes.
Could you make a peek to some of that itself?
Yeah, you can run them on the plan. I did not specifically, but like, so tfsec, for instance, let me close that. Let me go back a few slides.
So you could, for instance,
Yep,
try to migrate your
yep, yep.
codebase to something.
So some of these you can, tfsec, you can give the working directory, and then you can get to the rest of the arguments. And so the rest of the arguments, like I said, you could do the filtering and pass it specific TFRs or workspaces. Terrascan, there's a number of different specific formats, and I think checkov is the one that definitely has on the plan. I just looked right over it. There it is. Yeah, see, like an optional path to the TF plan. So, yeah, you can. Other questions? Yes.
In Pulumi, you can set a protect flag so that you have to explicitly unprotect the resource to be able to delete it.
Yep. There are resource locks in Azure. They require slightly different permissions out of the box than contributor, because it is a user authentic. Like you need either owner or user administrator permissions, I think, to set the resource lock flag. So if you just have a contributor for your identity that you're deploying to Azure, a lot of times that'll fail if you don't give it those explicit permissions it needs. But you can do resource locks with Terraform. You can say, I want to resource lock this resource group, that it can't be deleted or it can't be changed. That is something that Terraform supports.
Would that pick up recreating a resource if you changed?
Oh, it would fail when it tried, yeah. Yeah. Other questions? Got about, yeah.
Is there a specific reason you chose those three scanners?
The reason I chose those three scanners, tfsec is by supported by Aqua Security. I really like Trivy and a lot of the work they do, so that was one that popped up a lot. Like I said, with tfsec and terrascan, they both support, and I didn't have time to dive into it, and I apologize for that, but it supports rego policies, so you can define those as custom policies. Like I'd accidentally deleted it off of a branch, but you can have rego policies against your infrastructure, which is awesome. Terrascan is another one that's huge. They have integrated that into Nessus. They also support rego policies, and then checkov is one that I've been aware of for a while, both on the container space and on infrastructure. So that was the reason I picked those three. There are more, but leveraging it with GitHub, where you can run multiple simultaneously, you can have it through a pre-commit hook or in your IDE. It just adds layers of automation to help you catch, hey, I'm going to go make a storage account. That's perfectly safe, right? Maybe not. So, any other questions? Yeah.
You use Atlantis to find wiring these policies?
I have not used Atlantis yet. I definitely came across it. I didn't have time to fully integrate it into this, but
It works really nice with Rego. So, for any of you that don't know how it works, essentially
It integrates with your PR pipeline, and it runs the plan automatically for you, and then has the ability to go run policies at the plan, and will fail, so you can't even apply the Terraform to that.
yeah.
Those set of policies fail. So this is static. And
Yep.
You can do it at actual execution time as well. And you can do it at apply, and then if the policies fail after the apply, it actually rolls back the plan.
Awesome. Yeah, I definitely need to look into Atlantis more. Anything else before we're done for today? Well, I think we are at time then. Thank you everyone for coming today. It's my first time here at NDC and my first time in Norway, and it's been amazing and some awesome conversations, and I hope to continue it. So reach out.